Okay, hello everyone. Now the function session, we will be starting functions and graphs in paper one. It's one of the big sections over there. It's 35 marks around out of 150. Now there are questions with parabola, hyperbola, exponential functions, logarithmic functions, inverse functions, all these things, including the straight lines. X of symmetries, domain. So that's a lot of small terms and details that you may need to remember. But by practicing with a few past papers and understanding like what is, like, let's say X of symmetry, X-intercept, what is domain and range, so you will have a general idea of all these questions. Now, let's start with this question 3. The function can be defined in this way. So basically, a function is a relation between y and x values. So the x values are the domains that you know that in this case, and y represents the range. So this function, obviously, if we leave y alone, we will get the equation of function. So y is equal to x minus 5 square and minus 4. So by the way, on the other side, you already know y can be written as f of x. So you can even say f of x is x minus 5 square minus 4. So we know it's a parabola. Just remember the basics. And it is in TP form. I know the turning point 5 and negative 4. It's a heavy face parabola with a turning point. And if we want, we can find x-intercept, y-intercept, anything. Now, x of symmetry is TPx. So it's basically is equal to x is equal to TPx, which is x is equal to 5. What's x of symmetry? Is the line, is the vertical line coming there. Now, the x-intercept, you equate it to 0. So when you equate it to 0, you can just see, in this case, we have, we don't really need to open the brackets. If you leave it alone, so you get 4. So you get x, when we square root, so you get x minus 5 is equal to plus minus 2. So we got two answers. So x is equal to 7 or minus 2 plus 5, 3. And there are two x-intercepts, or say or, it's not the solution. Here we can say and because there are two x-intercepts. One of them is x is equal to 3, and the other one is x is equal to 7. So we can write in coordinate form or not really. So we can say 3, 0 and 7, 0. It doesn't say, but that's okay. Now sketch the graph with the turning points and x-intercept. So we didn't get y-intercept at the moment, but what is f0? It gives y-intercept. That gives us negative 5 square is 25, so it's 21. So then the graph can easily be drawn. So I can just draw quick on that side. So we can plot the values. What do we have? We have 3 and 7. Oh, I'm not very scaled at all. 3 and 7. Turning point is what? Turning point was 5 and minus 4. So somewhere here is a turning point, and y-intercept is 21. So the graph will be like that. Okay, so y-intercept is 21. So you can say that's 21. That's my 3, that's my 7, and that's my 5, and it's in the middle of turning points, 5 and 4. What is the range? 5 and minus 4. The range in a parabola depends on the turning point. It's either y is equal to less than or equal to q, or y is equal to more than or equal to q, depending on heavy phase or set phase condition. If it's set phase, it will be less than. If it's heavy phase, more than q, which is TPy. So in this question, it's heavy phase. So we can say y is more than or equal to negative 4. That's the minimum possible value that y can get. So that will be the domain of this function. Okay, so those are the x-intercepts and all. All right, then there's a transformation. What does it say? F of x transformed to g. X-intercept of g is the same as of f, but the turning point becomes 5 and 4. Describe the transformation. So what will be the new transformation? What has happened is the turning point become 5 and 4. Where is 5 and 4? On the top of that. So x and y-intercept turning point, nothing changed. So we have this function. That function is g, the one I just drew. What is that? That's my g. So it was f, so that's my g. The turning point become 5 and 4, as you see. I just draw there. And so what? It is reflected about, you can see, it's reflected about x-axis. Does it say describe. Yeah, so it says describe, so that will be fine. You can say it's a reflection about x-axis. Okay, and then 3.2 looks like a separate question. We have another parabola and a straight line. Determine the values of k if g if g a tangent to the graph f. So g is a tangent to the graph. Okay, it looks like kind of a calculus question, and we can solve using calculus method. It looks like we will need to do that. So what as the tangent keyword should remind you? It should remind us gradient is equal to derivative. Now in calculus, whenever you see tangent, you can say gradient is derivative, because it is good. I know gradient is our k, so that's fine. And derivative is what? I can take the derivative of the function, which is 2x. Okay, which is 2x for f of x. Derivative of f of x is 2x. So k is equal to 2x. When does it happen? We don't know that. So the gradient will be equal to 2x at a specific x value. So what should be that x value? So that one information, we can say gradient is equal to derivative. The other information is what? Wherever the tangent is, functions has the same value. Functions has the same y value. Functions are equal actually. The lines are equal. To visualize it, let me just do it. This is a happy face graph, f of x, and g of x. We don't know, is it decreasing or increasing? Depending on k, it can change. I don't know what k is at the moment, but it could be a line like that, or it could be a line decreasing line. So I just put c. So that's my g and that's my f. So the point they intersect, actually they are equal. So that's my other condition. F of x is equal to g of x. So if I equate them, I'll get my second equation, and that will help me to solve the question. So it's x squared plus 3 must be equal to what? Kx minus 1. So can I solve this equation now? It's like solving simultaneous equations. You have two equations. One of them is a straight line equation, you can say. So you'll substitute k into this one, and we'll be solving with the substitution method. So let's just solve simultaneously. I'll write on that side. So solving simultaneously, I can say x squared plus 3 is equal to 2x times x is 2x squared minus 1. So put everything one side. I can take one that side. So it is 4. 2x squared minus x squared is 2. So I'll get x is plus minus 2. Oh, I got two possible answers. So nice. So if x is plus minus 2, I can tell you k is plus minus 4. That's it. So that wasn't long when you just understand what really we have to do. Let me just go through that. We equate the functions. F of x is x squared plus 3. And then g of x is 2x times x. So 2x squared minus 1. Why do we do that? Because we substitute k with 2x. And then that's how we solve. So we got two possible values for x. So that makes two possible values for k. Okay, so that was a question which includes calculus actually. The idea is basically we have two possible values for k. That means there's a graph which is increasing, like the one we draw for k is 4, and then the other one is for k is negative 4, which is negative gradient. That will be such a line. So the two are both correct. All right, so that question was all about, let's say, parabola. The second one, we have, as you see, hyperbola. Now the graph is given. We need to find the values in the graph, in the equation. So A, P, and Q are missing. So as you see, P and Q is the vertical and horizontal asymptotes. So that you see that's x is equal to minus 1, and that's y is equal to 2. So that makes P is equal to 1, because what makes denominator 0 is x is equal to minus 1. Okay, and then I can just say Q is equal to as horizontal asymptote as it is, which is Q is equal to 2. So that's just 2 marks, but be careful. You may have just get confused with P. Is it -1 or 1? You can maybe do in that this way. You can just say, when do we have a vertical asymptote? When denominator is 0. So when x is equal to -p. And here we have -p is equal to -1. That's why we say p is equal to 1. I mean, you don't really need to show anything. You just need to write p is 1 and q is 2. Okay, because if you say p is -1, then it becomes x minus 1. And if in denominator it is x minus 1, then what is horizontal asymptote in, vertical asymptote when x minus 1 is in denominator? The vertical asymptote is 1, not 1. So that will be wrong if I say p is -1, okay? All right, then the next one. Determine the value of a. So finding any other value, then we need another point to substitute. So we can, so we already know p and q. To find a, I must have a point given on the graph. We have more than one actually. You can see that's 0 and 4 as a y-intercept, or we can say -2 and 0. I can use anything. So we can just say substitute whichever we want. Let's say 0 and -4. So 0 and 4. Substitute 0 and 4 into the a over x plus 1 plus 2. So how does it go then? If I substitute x with 0, y with 4, 4 is equal to a over 0 plus 1 plus 2. So it gives me a is equal to 2. Okay. So there we got a is equal to 2. Then let's see, the x of symmetry of f are, okay, they already drawn and they already given. Remember the x of symmetries, if we just go through quickly, this is the one which is increasing, m is 1, m is positive, which is 1. And that is the second one is the one which is decreasing, the gradient is -1. And both x of symmetries passes through the intersection of asymptote lines, so which is p and q, so which is -1 and 2, p and q. So they both pass through -1 and 2. Now, what does the question say? The graph of f is transformed to G such that x of symmetry of G are given in a different way. So describe the transformation. Now, to be able to make sure what is the new graph, new function, new G, it is, we better find that point. You see, normally the point for the x of symmetries intersect is the point where the vertical and horizontal asymptotes intersect. So vertical and horizontal asymptote intersect the same point as the x of symmetries intersect. It's the same point, all these 4 lines intersect. So vertical asymptote, horizontal asymptote, increasing x of symmetry and decreasing x of, they all passes through that point. So I can find that point by using the 2 given according to the new one. So I'm not going to worry much about what has happened, this x plus 1 plus 3 become -3, whatever. I will equate these two because they are my new, they are the x of symmetries of new hyperbola. I already know the one I have already, f, I know f. I just need to find G with these two. So let's do that. How do we get the point they intersect? Basically, we equate them to each other. So we can get the intersection point. So 2x is equal to 4. They intersect when x is 2. And when x is 2, what is y? Y will be -1. So the point they intersect become 2 and -1. It's just transformation. So nothing else change. Okay, it's just we move the graph up, right, down. So then it was -1 and 2. Now it is 2 and -1. So let me just make you think with the point now. So you had the x of symmetries. Okay, I can draw both actually, the new and the old one. It was -1 and 2. Okay, so it was -1 and 2. Let's make it like closer, and 2. And what is the new one now? It is 2 and -1. So that's the new x of symmetry. And the remaining of the graph stays same. Like what? how was the graph look like in this thing? It was like this and like that, isn't it? The graph that we have was this. This is the shape. And then the graph here is going to be like that. The things changed. But don't worry about the whole idea, like what happened or whatever. We need to focus that point. That point will be enough to focus. Which point? The point they intersect. What was it? It's basically the point intersect was -1 and 2. Now it become what? 2 and -1. So this is how you can describe now. Don't worry about much the other stories. So that idea, how come 2 minus 1, 2, B turn into, move into that new position? See, it was -1 and 2, the point those things intersect, and then now it become a new function. After transformation, it become 2 and -1. What kind of transformation is needed? You can just say shifted what? -1 to become 3 units right, and 2 become -1, 3 units down. Okay, that's it. It is shifted 3 right and 3 down, because -1 become 2, 3 right, and you can see that point move right and down, 3 right, 3 down. All right, you actually not really need to draw, but I just want to make clear with you the question. Let's read the question again. It says describe the transformation. Yeah, that should be fine then. So the previous X of symmetries, the original ones, we already have them. We already know the point A, and all is fine. We need to focus to figure out what is the new graph. I can get the equation of the new graph, but that's not the question. I can get the equation of G, but I don't need it. Using that point is enough for us to have an idea about this transformation and describe it correctly. Okay. All right. Now, yes, we had parabola, we had hyperbola. Now we are having exponential graph. Most probably that will have some inverses and everything, you see. All right, let's see. There's an exponential graph. The next question, a to the power of x plus half, and then a is positive, not 1, passes through -2 MP, and it is passing through another. So we know that 2 points that graph passes through. That's good. And determine the value of a. So any value on the graph missing can be determined by substituting the points, any point on the line of this function. So what can we substitute? We must find a first and then p. So to find a, we basically need to substitute the point, the coordinates of the point that we know, which is 1 and 5/6. We need to substitute it into y is equal to ax plus half. So do that. You can just say 5/6. 5/6 is equal to a to the power of 1 plus half, 1/2. So that gives me a. What is a? 5/6 minus half. So it is 1/3. You can use calculator anyway. So that's 1 mark. But then the second thing, 2 marks actually. The second thing, now I will substitute -2 and p in this new equation, because I already know a is 1/3 to the power of x plus 1/2. So I'll substitute -2 here to get p. So that will give me p is equal to, which is the y coordinate. Okay, obviously how you substitute is that's my x and that's my y, and this is my x and that's my y. So then p is equal to 1/3 to the power of x, which is -2 plus 1/2. So the first one gives me 9, 3 to the power of -2. It is 9. 9 plus 1/2 is 9.5, or you can say 19/2. So those are the first 2 questions. It's just substituting the points into the function to find the unknown in the function, and substitute the point again, so to find the y coordinate of the second point, which is p. Write down G, reflection of f about y-axis. So reflection about y-axis, what will be the story of reflection about y-axis? Y is equal to f negative x. So that's reflection about the y-axis. So then I already know f, so I can write g. So it was 1/3 to the power of negative x. So then it will become 3 to the power of x plus 1/2. So 1/2 doesn't change. So we just applied this idea like 1/3 to the power of negative x. So 1/3 is already 3 to the power of -1. So 3 to the power of -1 to the power of minus x becomes -1 times minus x, 3 to the power of x. Okay, so that's how we just write 3 to the power of x plus half. So you can actually just write 3 to the power of x minus half. Okay. All right. Then, and the next thing comes h. There's a new function h, which is g minus half, and you need to find inverse of h. So what is g from g? How do you get h? It is half less than, so h of x is given as g of x minus half. So it has plus half, that means it will disappear. That means the function of h of x is basically just 3 to the power of x. And you know how to get inverse of this, but let's just write a bit that long way. You substitute y and you swap x and y, so 3 to the power of y, and then you say y is equal to log 3x. So basically inverse of h, inverse function of h is log 3x. So you can remember, if you have 3 to the power of x, its inverse is log 3x, just like that. And then finally, calculate the average gradient of the curve between x2 and a. So x minus 2, and this is for f. So average gradient is basically, okay, we are asked to find average gradient between 2 points. One is the point -2 and p, and the other is a. So that's like paper 2 question, gradient between 2 points. Do we already know p? Do we already know a? Yes, kind of. We can just say the first point is what? -2 and p. What was p? It was 19/2. And then the other point, which is a, what is a? It's x coordinate is 0. If x is 0, what does the function give us? 3 to the power of 0. You can say, so anything to the power of 0 is 1. 1 plus half, it is 3/2. So these are my coordinates. So for average gradient is basically finding the gradient. So let's just do that. So the gradient is 3/2 minus 19/2 divided by 0 minus -2. So what do you get then? You'll get -16. So it is -8/2. So it is -4. That's all. So just finding average gradient is finding the gradient of 2 points over there. So, but first write aside the coordinates so you know what's happening. That's for question. That's for the last question. Okay, as you see, the solution doesn't really take that long. It's just for 10 marks. Actually, like for writing inverse, you may not really have to write all these steps sometimes, or even those things which you don't need to write, substitute. You just substitute. So the examiner will see you what you are doing. You substitute it. You don't need to really explain what you are doing. Okay, then let's see, is anything different here? There's a hyperbola. We need to draw the asymptotes, so x-intercept and x of symmetries with the negative gradient. So all seems fine. It's just, I will remind this x of symmetry with the negative gradient, it's -1. So it's actually -x plus c. And remember, we must substitute which point? The asymptotes, which is 1 and 2, to get c. So I know there's vertical asymptote, that's horizontal asymptote. Oh, by the way, just to not lose mark, don't write the vertical asymptote is or horizontal asymptote is 2 or 3. Write the equation, because it says, look at the equation, it says equations. Don't tell me 2, -1, 3. Write proper equations. How do you write equation of a horizontal line? Horizontal asymptote. Equation of a horizontal line is y is equal to 2. So it's y is equal to 2. That's it. Don't write just 2. Don't write the point, coordinates of a point. And vertical asymptote, coordinates of, equation of a vertical asymptote, vertical lines, actually, in general, is x is equal to something. So x is equal to 1. So write in this way. So just please, don't just write 2 or 3, just write 1 and 2 or whatever. Write proper equations. It's a horizontal line equation. That's a vertical line equation. So it's horizontal asymptote, that's vertical asymptote. Okay, I think the rest looks like fine in this question. You can just check the next set. Okay, what do we have here? Now that's kind of two graphs on the same question given. What is that? There's an exponential function and there's a parabola. Yes, all is good. And they have the same y coordinate, y intercept, and we have any point. It's half. That's actually turning point. All right, the lines parallel if are indicated. AC parallel to, where is AC? Okay, AC is parallel to x-axis. So that's good because we will use the idea of x of symmetry to find coordinates of C later on. So it looks like we are given almost everything in the diagram. So I'll just write G is what? AX squared plus BX plus C, and f of x is k to the power of x. And the coordinates given, so they have the same horizontal line. Yeah, that's a little bit move out, and we'll see. What's the coordinates of A? Now k to the power of 0. So we can substitute with f0, and f0 is k to the power of 0. Basically, as long as it's k is not 0, okay, you can see it's not 0, it is 1. So the coordinates of A, don't write just 1 again, because the coordinates, they may be expecting you to write 0 and 1. Okay, write it like that, please, even if it is 1 mark. And to find k, now remember, we need another point to substitute. Any other point on the graph on this line is B. So that's what we will do. We substitute coordinates of B, which is what? Which is half and 2 in what? In which equation? In y is equal to kx. We don't know k at the moment, yes, but we can find it here. So it is 2 is equal to k to the power of 1 over 2. Am I right? So you substitute x with 1 over 2 and y with 2. So how do you find k then? We can square both sides and get the answer. K is equal to 4. So that means f of x is 4 to the power of x. And finding equation of parabola, what we know the turning point. So I use TP form. And what is turning point? Turning point is half and 0. So, and we have another point, yes, which is A, coordinates of A is already given. So let me just do it up there. So we have turning point, so we can say y is equal to A times x minus p squared plus q. So that's TP form. Now y is equal to, we don't know A as yet. So x minus turning point is 1 over 2 squared plus 0. So how do we find A? Remember, we substitute another point, so which is y-intercept, which is A. So we substitute coordinates of A, 0 and 1. So what do we get then? It's 1 is equal to A times 0 minus half square. So 0 minus half square is 1 over 4. So it's A times 1 over 4. So then we got A is equal to 4. So since we got A is equal to 4, I can actually write the equation y is equal to 4 times x minus 1 over 2 squared plus 0. So that's my equation. But the thing is, equation given in the graph in standard form, that's correct. But we have to convert it into that form to find A, B, C. Remember, A is always same. Like I got A4, and even in the question, as you see, A becomes 4. So how can I get those other values for B and C? Please never ever substitute and make an assumption. Actually, let me write it down there. Never ever assume as A is equal to 4 or B is equal to minus 4 or C is equal to 1. Okay, do not make any assumption. Do not say, oh, these answers work. See, they are not telling you, check these answers are working or not. You know, you need to find them properly, just like as you don't know. So how do you open the brackets? Let's do that. You need to open the square of that. So it's x squared minus 2 times, so it's minus x plus 1 over 4. So just be careful with taking that square. Huh? Be careful. Let me put some explanations. So finally, 4x squared minus 4x, and 4 times 1 over 4 is plus 1. So that is my equation. And that's why I can tell you A is 4, B is minus 4, and C is 1. All right. Now, determine the inverse of f. So that's fine. It's what 4. So I'll just write, I'm not going to take long this one. So 4 to the power of x. Yes, that's the original function. So the inverse of 4 to the power of x is log 4x. You can swap x and y values and so on. That wouldn't be a problem to write in use. That's nice. Now, the next one says determine equation of h, reflection of f about y-axis, reflection of f about y-axis. So it's going to be the new function, h of x will be reflection about y-axis. It's negative of f of x. Basically, we can say negative 4 to the power of x. That will be upside down. Okay. Range of g, we mentioned in the previous question, that's about y is more than or equal to TPY, which is 0. Okay, because this is happy face, we can just write in that way. Good. And then the next one, equation of tangent tangent to G at C. Okay, again, this question is kind of a calculus question because tangent gradient is what? Is the derivative. So I need to find the derivative of this function. So what is G of x? Is we got there 4x squared minus 4x plus 1. So what is the derivative of G of x? So the derivative is 8x minus 4. So what are the coordinates of C? Okay, the good thing is that's because of x of symmetry, so that distance will be same. So this will be 1. The x coordinate of C will be 1. And the y coordinate, I need to find the substitute 1. So to see the y coordinate, actually it is same as A, isn't it? So y coordinate will be 1 as well. So that's my C, 1 and 1. And I will get gradient by substituting 1 into derivative. So that gives me 4. So that's like everything now. I have the gradient, which is 4, and I have the point. So I have the point and I have the gradient. So I can get equation of tangent. It's 5-mark question. So it's more calculus question inside functions now. So I can just substitute y minus 1 is equal to 4 times x minus 1. So the answer is y is equal to 4x minus 4. So it's 4x minus 3 will be the answer. Okay. And then the questions, questions with inequalities like such given, we just need to understand this idea again, if you remember, to be able to have the product positive, they are both positive or both negative. Now, both positive means, because this is derivative, be careful, G increase and F above X, or other way around, G decrease and F below X. So from the graph, we will be looking such conditions whenever we have G of X increasing and F of X above X, or other way around, G of X decreasing and F of X below X. So that intervals will give us the answer. So let's complete this part, the last 3 in our next section. It was a nice long question. So there are a lot of things we can learn from this question. So we will be completing last 3 in our next period. Our time for Zoom is up for now. Thank you.